Hello learners, welcome to this course on Arduino Board programming and simulation. In this tutorial, I will be discussing about on how to perform a serial data transfer using UART protocol in Atmega 2560 microcontroller. So this Atmega 2560 microcontroller is part of your Arduino Board. So here in this Arduino board, we have 4 hardware UARTs. So UART stands for Universal Asynchronous Receiver Transmitter, where the transmission of data happens in a serial format. A bit by bit transmission occurs. So we have about 4 UARTs in Arduino board, so which is named as serial 0, serial 1, serial 2, serial 3. Usually this serial 0 will be connected to your computer and it will be used for the programming of your microcontroller. So we can also reconfigure this as per our requirement. So in this tutorial, I will be using a serial 2 communication for transferring the data from your microcontroller to PC and from PC to microcontroller. And this UART, it supports TTL logic. As I said, UART stands for Universal Asynchronous Receiver Transmitter, which means the data transmission happens asynchronously. Without the help of a clock signal, the data is being transmitted. So the data can come at any time, at any point of time. So the receiver and the transmitter can be sent the data or receive the data at any point of time. So it has a dedicated hardware that performs this asynchronous serial communication. So here in UART we have an option of configuring the data format. So the data which can be transmitted by the UART can be varied from 5 bits to 9 bits. So we can have a packet with different data sizes. So the data size can be varied between 5 bit to 9 bit. And the transmission speed also can be varied. So the transmission speed is usually measured in terms of a baud rate. Baud rate is number of bits transmitted per second. And this UART protocol, it works with different voltage levels. For example, in a microcontroller, the logic 1 is represented by 5 volt, logic 0 is represented by 0 volt. Whereas in case of a computer, if I take logic 0 is represented by plus 12 volt and logic 1 is represented by minus 12 volt. So there is a drastic change in the electric signaling levels from one device to another device. So if I want to send one from microcontroller to a computer, so 1 is nothing but logic 5 in the microcontroller, whereas in case of a computer, it is minus 12 volt in the computer. So thereby we need to have a driver circuit which handles this signal conversion process. So I will be discussing about this driver circuit, which is MAX 232 IC, which will be using it for electrical signal conversion process. So the main application of this UART is to communicate over a computer or any peripheral devices such as mouse, monitor, printer, etc. If I take a UART communication, let us assume the two devices have the UART protocols supported. So how the connections should be done? So from one device, the receiver line should be connected to the transmitter line of other device. And same way, the other device receiver line will be connected to the transmitter line of the first device. And this signals, transmitter and receive signals will vary with respect to the ground line. So thereby it's a full duplex communication. So simultaneously the data can be transmitted and the data can be received in parallel. So thereby it comes under your full duplex communication system. So if you look at the data format, by default the line transmitter and receiver line will be in a logic 1 state, which is an idle state. So during the data transmission process, there will be a transition from logic high to logic low, which indicates the start bit. So the start bit is indicated by a transition in the line from logic 1 to logic 0. Then comes the data bits. So the data bits can be varied from 5 bits to 9 bits. It is user configurable. So usually in the data bits, the first bit after your start bit will be the LSB bit. And finally your MSB bit will be transmitted. Then after the data transmission, we have an additional option of parity bit. So the parity bit can be included or not. It is again an optional bit. So even parity means even number of ones in the transmission. Odd parity means odd number of ones in the transmission. So usually the even parity will be represented by 0 in this position. Odd parity will be represented by 1 in this position. Then comes your stop bit. So stop bit is just the opposite of your start bit. So here we will have a transition from logic 0 to logic 1. That represents the stop bit. So a start bit is given by high to low transition. Then comes the data bits. In the data bits we have LSB to be transmitted first, MSB to be transmitted last. Then we have an optional parity bit, odd parity or even parity. Then finally comes your stop bit, which is a logic low to high transmission. So let us look at the data format. If I want to send M, capital M. So the capital M is represented by its ASCII value. So the ASCII value is shown here 1001101. So if I count the number of ones here I have 4 ones, which is nothing but an even parity. Then what will be the signaling levels in a UART protocol? First there is a start bit, which is nothing but a high to low transmission. Then comes the LSB part. So LSB is this one. So 1 is transmitted. Next is 0, 1, 1, 0, 0, 1. So this completes the data in the packet. So first the LSB, finally the MSB. Then comes the parity bit. Since it is an even parity, the parity bit is set to 0. Then comes the stop bit. So stop bit is again 0 to 1 transition. So here the logic high and logic low. In case of a microcontroller, logic high is 5 volt, logic low is 0 volt. For a PC, it will be represented as logic high as minus 12 volt, logic 0 is represented as plus 12 volt. So let us see a signal format in PC side. For example, if I want to transmit J, capital J, its ASCII value is 0x4a. So 4a is nothing but 01001010. So if I want to transmit this in terms of a PC side, so first there is a start bit. So start bit should be logic 1 to 0. So logic 1 is represented by minus 12 volt. Logic 0 is represented by plus 12 volt. So there is a transition from minus 12 volt to plus 12 volt. So this indicates the start bit. Then comes your LSB part, which is B0. B0 is 0. So 0 means it is plus 12 volt. Then comes your 1. 1 means minus 12 volt. So like that the data goes on till B7. After B7, if I count the number of ones here, it is an odd parity. We have only 3 ones here, so it's an odd parity. So odd parity is indicated by logic 1. So logic 1 means it will be a plus 12 volt, and then finally your stop bit. So stop bit is a transition from plus 12 volt to minus 12 volt. So this is the signaling format in the computer side. So in order to convert this voltage levels between a microcontroller to a computer, because here in microcontroller it is 0 to 5 volt variation, whereas in a computer it is plus or minus 12 volt variation. So in order to achieve this, we make use of a MAX 232 IC. So here I show a MAX 232 IC, which is a 16-pin IC. So this, if you look at this, you have a voltage doubler circuit in the IC. So voltage doubler in the sense from 5 volt it can be doubled to 10 volt. Same way there is also an voltage inverter which can convert from plus 10 volt to minus 10 volt and minus 10 volt to plus 10 volt, vice versa. So we make use of these capacitors to help in this purpose. Then there are two sides. One is the TTL side, another one is RS-232 side. So TTL side is logic high is 5 volt, logic low is 0 volt. In RS-232, it will be something like logic 0 will be plus 12 volt or 10 volt or 9 volt, and logic 1 will be minus 12 volt or 10 volt or 9 volt. Same way we can connect two devices to this MAX232 IC. So here we show a typical circuit diagram where we make use of a capacitor of 10 microfarad or 1 microfarad is connected for this voltage doubling and voltage inversion process. So the lines coming from a microcontroller, it goes to this T1 in and R1 out, and the output from the MAX232, which is a level shifted or doubled value, it comes out from the T1 out and R1 in. So this gets connected to a DB9 connector. So this DB9 connector will get connected to the computer. So here the receive part from the MAX232 is connected to the transmitter in your DB9 connector. Same way the transmitter part of your MAX232 will be connected to the receive pin of your DB9 connector. Now let us look at this DB9 connector. So the DB9 connector comes in two formats, a male as well as a female. So here I have shown the male DB9 connector and the female DB9 connector. The pin number gets differed. So for a male connector, on the left side you have pin number 1, it goes till 5, and then in the second row you will have 6 to 9. Whereas for a female connector, it will come from the right side. So from the right side, the pin number 1, and it will go towards left 5, and from bottom right 6 to 9. So if you see the pins, essentially we use only 3 pins: TXD line, RXD line and ground lines. So these 3 lines are used for data transmission purpose. So other lines like DTR is a data terminal ready, CD is a carrier detect, RI is a ringing indicator, CTS is clear to send, RTS is request to send, DSR is data set ready. So these other pins are used in the handshake mode. So it is something like a handshake signals, whether the data is transmitted or not, whether the data is requested or not. So like that, it is mainly used for handshake of the data transmission. So generally we use the 3 lines TXD, RXD and ground line for transmission purpose. So now in this program, what we are going to do is we are going to take a Atmega 2560 and I'm going to use serial 2. We have 4 UARTs. We are going to use serial 2 UART, which has a pins TXD2 and RXD2, which is at pin number 16 and pin number 17. So this gets connected to the MAX232 driver. So at this point you will get logic high and logic low is represented by 5 volt and 0 volt. In the output of your MAX232, we will have plus or minus 12 volt coming out from T1 out and R1 in. It is connected to your DB9 connector, and the DB9 connector is connected to your computer. So in this program, what we are going to do is we are going to send a data from microcontroller to the PC, and we are expecting a data from the computer. So if the computer sends logic 0, then we will be switching off this LED connector to pin number 13. If the data sent by the computer is logic 1, then we try to switch on the LED. If the data sent by the computer is 2, we will try to toggle this LED for 1 second. Toggle the LED for 1 second. So this is what we are going to do in this application. So from a computer, so first initially the microcontroller is going to send the data to your computer, and it is waiting for the response from the computer. So the response from the computer can be any of these 3 values, 0, 1 or 2. Depending upon this response, the state of the LED will change. If the received response is 0, LED will be turned off. If the received response is 1, LED will be turned on. If the received response is 2, LED will toggle. So we try to look at this program. So for this application, we will be making use of Arduino as an IDE, integrated development environment, where we will be writing our embedded C program, convert this embedded C program into a hexadecimal file. Then we build the circuit using Proteus 8 Professional. We dump that hexadecimal file onto the Arduino board in the Proteus 8 Professional, then check the logic whether it is working properly or not. So let us go and visualize the circuit first. So here we have an Arduino based circuit which is developed in your Proteus 8 Professional. So here we have Arduino Mega board. So in this Arduino Mega board, I am going to use this TX2 and RX2 line, which is a serial communication 2 line. So this is connected to your MAX232 IC. So in MAX232, TX2 line is connected to T1 in, RX2 line is connected to R1 out, and from the MAX232, T1 out is connected to the RXD line of a virtual terminal. Same way R1 in is connected to the TXD line of your virtual terminal. And we have the supporting capacitors for voltage doubling and voltage inversion purpose. So then I have also connected an LED to pin number 13. So depending upon the data received from our virtual terminal, the status of the LED is going to get modified. So if it is 0, LED will be off, 1, LED will be on, 2, LED will be in toggling state. Now let us go and write the embedded C program in Arduino environment. So here we start with the setup function where we try to do the configuration part. So here since we have connected LED to pin number 13, we have to declare that pin as output pin. So pin mode 13 is configured as output. And I am going to set that pin to low. By default, the LED will be in off state. Then I am going to initialize the UART communication. Here we are using serial 2. So we put serial2.begin with 9600 baud rate. So one important thing is when I specify a baud rate, the receiver also should be in the same baud rate. So both the transmitter and receiver should be in a same baud rate so that the data transmission can happen properly. So we configure the UART with a baud rate of 9600 bps. Then from microcontroller, we are going to send the text start to the computer. Then in a while loop, we are going to check whether any data is received from the computer. So that is checked using this serial2.available. So once some data is received, we try to read that data and put it onto a variable data underscore receive. Now I am going to check whether the received data is 0 or 1 or 2. If the received data is 0, I am going to set the LED to be in low state. So it will be in off state. So I print the status on the virtual terminal also. Same way if the received data is 1, in that case I am going to switch on the LED. So LED which is connected to pin number 13, that is changed to a state high. Then we also put the status onto the virtual terminal. If the received data is 2, then I am going to run a function which is called as toggle LED. So here I have written the toggle LED function. So where I try to put the status onto the virtual terminal, and for 3 times from I equal to 0, I less than 3, which means I0, I1, I2. For 3 times I am going to toggle the LEDs. So LED goes to high state for 1 second and then it comes to off state for 1 second. So 3 times the LED will be toggling. After toggling 3 times, again it will come back to the main program. In the main program, again it will check for the received data. So for 0, LED will be in off. For 1, LED will be in on. For 2, it will be in a toggling state. Once the program is written, we can compile the program, convert this program into a binary format, hexadecimal format. So you can go to Sketch, export compiled binary. It will create the hexadecimal file. Once it is done, we can go to the Proteus environment. Now we have to put that hexadecimal file onto your Arduino board. So right click on this, edit properties, select the program file. So the program file created is UART_LED. So this is the hexadecimal file. So this file we are trying to import it onto your Arduino board. And another thing is you have to set the clock frequency also. So here I have set it to 16 megahertz clock frequency. Press OK. So now we have dumped the code onto your Arduino board. Now let us check the logic of the program. Press the play button. You can see the data from microcontroller is start. So it has come to the virtual terminal. Now it is waiting for the input from the virtual terminal. So this virtual terminal is something similar to that of a computer. So now in a computer I am going to press 0. So 0. So it says LED off. LED is in off state. Now I am going to press 1. When I press 1, you can see the LED turns on and the status is also given in the virtual terminal. Now when I send 2 LED in toggling state, here you can see the LED toggles. So it will toggle for 3 times and then again it will wait for the input from the user. Now if I want to switch off this LED, I press 0. So LED will be in off state. Again when I press 1, it will go to on state. Press 2, it will go to toggling state. So with the help of this UART communication, we can send data to a GSM module. We can get the data from a GPS module. Whichever device works with the UART protocol, the data transmission and reception can happen using this type of mode of communication. So in this tutorial, I have discussed about on how to use a UART protocol for data transmission and reception between 2 devices, and why we need to use a MAX232 IC for the communication purpose. Thanks for watching. Please subscribe for more technical learning. Thank you.